do a better job of controlling some things. Okay, and I checked in with every group yesterday. I thought you guys were running the investigation just as we planned. Is there still room for error?
Yeah.
Totally. Okay, so I want you to know that in our middle school classroom, I cannot make this a totally dark room. Okay, I cannot get flashlights that are exactly the same intensity. I tried, right? I cannot like tell you exactly when to hit that whole button. And so even though we may, or the toilet paper tube thing, do you still think that based on how everybody did it yesterday, it's possible we could still compare the data that we got? Yeah, I think so. So even though some of these differences may have happened, today we're going to walk through what scientists do to actually really make sense of the data, especially if we all had different incoming lights to start, okay? Okay, so let's stop. What do you notice now if we look at all these numbers here, and I want you to think about how do these numbers compare for transmitting light than any of the light that's coming off the flashlight? What do you recognize about all these numbers? Lola?
They're a lot lower because it had to burn something.
Yeah, these are really low, right? This is like saying, hey, the light that's coming off the flashlight should be way bigger than the light that's coming through the one-way mirror. Does our data help support that idea that we've been saying all? And I want us to begin thinking about how we can, you guys pushed for a way to measure these the light sources, but I want to think about placing our values on a number line. So what I would like you to do is to think about where would you place each of these three materials on this number line regarding its transmission of light and reflection of light. Okay, so let's think about this. Okay, let's say, for example, that 50% of my light transmitted and 50% of my light reflected. Okay, I would maybe take my material and place it somewhere between 0 and 100%, right? Because it's about 50%. But let's think about this. Let's just do one material at a time. Let's just do that, okay? So everyone find your data that you had for, what's the first material we tested? One-way mirror?
Yeah.
Okay, so if a one-way mirror, and this is where you're gonna have to use your data, okay? We'll just focus on the top half of the number line. So almost take your hands and cover up the word reflected, okay? If on this number line, okay, and I want you to stay above the number line, almost like in the shaded place here, okay? Okay, I want you to write where would your one-way mirror go based on the data that you collected. So if my one-way mirror's data was like 2%, I would have to write like one-way mirror closer to here. That make sense? If my one-way mirror transmitted 50% of the light, I would have to move one-way mirror to the middle. So work with your table. Where would you put one-way mirror? All right. So how many of you find this is hard to like compare them? But is it easier to compare them now that we have numbers?
Yes.
Way better. So I think your idea to compare with numbers was helpful. Okay. So I want us as a class to kind of summarize and come to like an agreement. Even though different groups got different data, so do you feel like there's any materials that kind of stand out in terms of who transmits the most or the least? And maybe as a class we can come to an agreement moving forward. Was there any data that we have that we're like, oh yeah, now that we've got numbers, we absolutely know something is true? Do any of these materials reflect the most, or transmit the most, or reflect the least?
Yeah, the mirror reflects like probably the most because.
How many of you agree that the do we have data to support that now?
Yeah.
Okay, so down. So keep those data tables open. Keep those data tables open. Can everybody still see?
Yeah.
Okay, back on track. Nope, I just want you to watch, because I want to point. I need you to help me, because they heard all these really great ideas. So when I looked behind Amber over there, this is the last idea that we came up with. We said, we think these things are happening. But now that we've got some amounts, I think it's really important that we can actually take our model, and every time we get new evidence, we can improve the models that we're developing. All right, so I want us to first start with the one-way mirror. Can you remind me, what did we say happens when light hits it? Go ahead. It reflects really well? Does the one-way mirror only reflect really well?
No.
Does light go through the one-way mirror?
Yes.
Look at you talking about, yeah, it transmits, right? So I want us to think about something. Remind me, when did we say that light would be the biggest? Or the highest amount? think back to when you guys collected data as a group. When did you get like the biggest readings on the light meter? Jonathan?
When like close up to a light source.
Close up to a light source. Do you guys agree with that?
Yeah.
Okay, so I'm going to start our model for us today thinking about how we have been representing all the lights. So I'm going to go ahead and draw a solid line here. So would you guys agree that anytime light interacts with the material, the first thing is that all the light goes to the material?
Yeah.
Okay, so up here, I'm going to pretend that this is my light source and it's coming to the one-way mirror. But we also know that every time we measure the light coming off of something, you guys told me that the value gets less and less and less, right? So remind me, when light hits this mirror, what does it do? It reflects, but it also does what?
Goes through.
Transmits. But isn't the same amount?
No.
Okay, so does anyone have any suggestions? How can I change this to now show this new evidence that as a class, we've figured out? Noah?
You could do like a dotted line through it.
Maybe some dashes.
Or dashes, yeah.
Oh, dashes or dots?
I feel like dots should be for a little light.
And then
Maybe
like,
dot.
long dashes for most of the light.
and like some light should be
Short dashes
Most
for
light dashes. Most light should
Okay, Jonathan.
Hold on, I can't hear everybody talking at once. Gia, what were you saying?
I think that most light should be dashes, some light should be dots, and a little light should be like pencil.
Oh, it'd be even less? If we change colors, though, that might be confusing with people that we're changing colors like. What do you guys think about this idea of like changing the type of line? Like Noah first suggested, do dashes?
Yeah.
Yeah.
Could I do like bigger dashes and little dashes?
Yeah.
Yes.